Hi, everyone, and welcome to this week's episode of The Context. We have an awesome show for you today, and Darren is back and here with us. Darren, thanks
Hello.
for joining it today.
I
Um,
barely made it in time. My car battery died, and I had to get that fixed to make it here in time. So I'm excited.
wow,
Yeah.
it's funny. My wife had a flat tire yesterday, so it was like everything, all
Yeah.
car problems, hopefully now resolved. This is our 20th episode. I don't know if you knew that.
Holy cow.
Yeah,
Wow.
it's been. I was like, so if we do two, that means we've had 40 presentations since late
Wow.
May when we started this. It's
Yeah.
amazing how many people are working on MCP, building out new things, and yeah,
To
it
be
was.
perfectly honest, I thought we would quickly run out of people to talk, but we have a
You know what?
huge queue
Ye of little
like,
faith. See, I had
yeah.
confidence. I knew people would want to talk. There's
No, I
just
thought it would fizzle out so fast.
yeah. Who wants to work on AI integration with systems and data? Like that's not interesting at all. Well, for those of you who are seeing this maybe for the first time, I've mentioned this a couple times, but all of the sessions from our big MCP Dev Summit in London are online now. There's more than 30 talks. They're all on this YouTube channel if you're watching us on YouTube. And there are some truly fantastic talks. I would highly recommend watching David Soryaparo's talk from Anthropic. He kind of outlines what's coming out in the next big release of the MCP spec, which is scheduled for next month. So if you haven't seen that one, go find that. There's also at least 4 different talks about approaches to managing tool calling at scale, which I thought were super interesting. Great updates on where the registry is at, where the registry is going. So all of the maintainers and project leads tended to be there. There was an awesome panel from financial services companies talking about what they're doing with MCP. We had the CTO of Bloomberg who came and talked about just the rapid expansion of MCP within Bloomberg. So if you're excited about MCP, you will warm the cockles of your heart to see all these other people who are excited as well.
Yeah, it's pretty cool looking over the talks because you can see how we're when a new technology comes out like MCP, there's like kind of like, oh, it'll never work because of X, Y, and Z or whatever. And to see how, as this is maturing and how we're finding kind of like logical, simple solutions to things, like the tool scalability one is a really interesting one. And the solutions are really simple, actually. So.
They are, but though there's competing ideas too. I think we're at that stage where there's not like one way to manage a lot of tools when you're trying to build an interesting talk. In fact, I think I'm looking forward to Misha's talk today because Misha's going to talk a little bit about, I think, a real world use case where they have to deal with a relatively complex set of tools. Put the date on your calendar if you haven't already. We are coming back with the next MCP Summit. This will be in New York City next spring. We are getting close to opening up the call for papers. We're getting close to opening up sponsorships. We had some sponsorships sold out really fast for London. We obviously would love people to attend this event. So please, if you are thinking about it and you want to get involved, we're absolutely looking for people who want to help with the program committee as well. So reach out to us on socials and let us know you want to be involved.
I'm predicting this one's going to be huge. The New York one is going to be.
Well, we moved it to 2 days. I think like the first couple were 1 day. I mean, San Francisco was 1 day. The New York one was 1 day. This community's grown bigger. The number of, earlier this week, I spoke at GitHub Universe on a panel with a number of other people. It was like a lot of the people were talking about our event in London actually and saying like, well, if you can tell when a community starts to congeal because suddenly there's sort of, events that bring 500, 600 people together that want to work on stuff. So it was really cool. Yeah. I think that, GitHub, they had a whole MCP universe, not even a track. It was like a night where, I think they had 800 people who wanted to attend and they could only fit 200 in. So when you're oversubscribed by 4X, that's a very good sign that there's real adoption happening.
Yeah. I'm always skeptical. And so I didn't really think London would pull off very well, but it was an amazing conference. But what I was very impressed with the conversations that I had with people like in the halls and stuff is like the substance behind it, the problems people are solving, the way it's being used. It's like, this is going somewhere. That's why I think this next, and just everything that's happened in the short term since There's been a lot of amazing developments in the MCP space. I think this April conference, it's like, honestly, if we had it like in February, it would still be huge. But like by April, yeah, it's going to be massive.
Yeah. With that said, if you are interested in following up on any of these topics, you will also find lots of awesome talks on our context channel. Like this is our 20th. That means we probably have 40 talks out there about everything from things like tool calling to security to building MCPs to using MCPs to building agents with MCPs to agent platforms to pretty much every company that's doing cool stuff with MCPs and gateways and security and management. So please take a look at the channel. And if you'd like to join us, submit, you can scan that QR code, submit a talk. We're always looking for interesting talks. We have lots in the queue, but I think we're going to have some really interesting ones coming up. After today, we have a couple of talks that are on areas around security and identity management, and I think there's a couple interesting ones coming on sort of adoption. So was talking to someone about kind of a adoption model and what does a maturity model look like around MCP. So I think we're going to see some really interesting talks now as people start to go beyond pilot phase into what does it look like when my organization wants to put this into kind of a standard layer for adoption. So lots of great talks, lots of great stuff coming. So if you haven't seen the context before, it is a pretty fast hour. We go through 2 talks. They're generally quite kind of presentation like. We try not to be, it's not really meant to be a podcast. We like to let people speak and present their ideas. So it's a lot like attending the sessions at the conference. So we go for about 20 minutes. Our speakers will have a rough stop around that 20-minute mark, and we'll take questions from the audience, or Darren and I will ask questions at that point. So with that, let's get started. We have 2 fantastic talks today. Our first talk is from Hailey Quach. Hailey and I connected online because I read her paper. She works at IBM Research and did an amazing paper, probably the best I've seen, on MCP security. And she really got into the details of the different types of risk. It was very well thought out. And I invited her to come and present and talk because I was so impressed with her paper. So I'm really looking forward to Hailey's talk. And after Hailey, we'll have Misha Kaletsky, who's one of the founders at a place called Iterate, iterate.com. And Iterate is building some really cool multiplayer MCP. So multiplayer agents that use a lot of MCPs. But it's I don't want to steal his thunder. This is something I think you're going to want to stick around for. Jonas actually was the one who kind of clued me into what they were doing. And once I saw it, I was super excited to have Misha on the context. So should be really good talks today. So Misha, Hailey, thank you so much for joining us. Hailey, the floor is yours.
Yeah, thank you for having me. Okay, so let me share my screen first.
Hailey, you're joining us from Ontario, right? Just outside of Toronto?
Yes. So yeah, IBM at Markham, Ontario.
Awesome. Well, thank you for being here, and we look forward to the talk.
Yeah, thank you for having me. So like Shannon was mentioning, I wrote like a blog post on MCP security, and basically today's talk is gonna cover the blog post as well as like some extra things that I came up with to make this talk like more valuable for you. We're gonna go over like the common pitfalls in MCP security, some suggested best practices and ways to mitigate these pitfalls, along with some real-world lessons, like real-world incidents, and what we can learn from them. So just quickly, a quick introduction about myself. My name is Hailey. I've been with IBM for more than a year. I am an AI information developer. So as an aside, I also write for Towards Data Science. So this is where I publish a lot of content on like the newer protocols in the AI world, like model context protocols and agent-to-agent protocol. So let's start with a quick recap of what MCP is. So if you watch the context streams, or if you're already familiar with developing MCP servers, I just want to give you like why it matters and what it is. So a quick history lesson is we started with a single LLM. So these are big reasoning engines, but they are stuck with their training data and no way to call out live tools. And then we go to the next step, which is tool binding. You can think of lane change where you attach tool directly to an agent. However, the hard part here is application integrations into like IDEs, chat apps, and other UIs. Each of them needs like custom connector for every tool, which becomes like a brittle tangle of point-to-point integration. And this where MCP comes in. It solves that by adding a standard centralized layer. So we have the model is the LLM, and the context is the extra data the model needs. And the protocol is the common language that lets like apps and tools talks to each other predictably. And if you have watched the talks from the MCP Developer Summit, you understand that like adoption of MCP is really fast. It's like exploding because MCP is the plumbing that lets agents call tools and data sources. It's elegant and it's convenient. However, because that convenience is also what makes mistakes very costly. In my blog, my paper, I already noted like different real world incidents, such as like the MCP inspector, this from Anthropic, where the tool endpoints was left reachable from the network. It was bound to 0.0.0.0, and it had no authentication at all. So when an attacker sent requests to that endpoint, which caused the server to execute commands on the host, this is like full remote code execution. And Anthropic has already fixed up this security threat, but there are other patterns that are still happening nowadays, like token leaks in plugins and prompt injections directly in the tool. And this is why MCP security is becoming more and more important. It is not just an afterthought for developers who are developing MCP server anymore. And then here I just want to give you like a big overview and summary of all the common MCP security pitfalls. I'm sure that like you have heard a lot of other speakers mention these, but I want to give you like a quick recap of everything I have like came across so far. So one fundamental challenge is ensuring that MCP facilitated actions occur with proper authorization and context. When an MCP server performs an action on behalf of a user, there is a risk of a confused deputy scenario. So that's what is being illustrated in the diagram you see on the screen here. In an ideal design, the server would execute actions strictly under the requesting user privileges. However, in practice, if not implemented correctly, an AI agent could unintentionally use the server's own elevated privileges or store credentials to access resources that the human user shouldn't have access to. So currently, MCP authorization model is built upon OAuth for delegating access tokens, but early versions of the spec had gaps that clash with enterprise security practices. For example, static OAuth client IDs and implicit trust in consent cookies could allow token reuse attacks if a server didn't explicitly enforce per user. And efforts are underway to update the MCP auth specification to better align with secure patterns. For example, like enforcing dynamic client registrations. But if you have watched the talk from Paul Carton from Anthropic on why MCP auth is hard, you should see that these efforts are not easy to implement. And then beyond conceptual auth issues, real-world MCP servers have exhibited like classic software vulnerability as well, showing that insecure coding practices carry over into this new AI tool ecosystem as well. So while MCP's design has conceptual security features, the actual code behind many tools is often flawed, especially in community or open source projects. So a real case is, as you can see on the screen, is from Anthropic's reference SQLite MCP server, which contained a simple SQL injection bug. The server concatenated user-provided text into an SQL query without proper sanitation. And this flaw, although documented as non-production example because Anthropic has classified it as not priority and archived the server, this server was widely copied. It was forked over 5,000 times by developers building their own agents. Consequently, the bug continues to live on in derived projects, creating exploit path where an attacker can embed SQL comments via an AI's input, potentially altering stored data or injecting malicious prompts into the agent's context. And then prompt injection is another very common security pitfall, not just for MCP, but in like the broader LLM application development. So prompt injection refers to malicious or unintended instructions hidden within the input text that cause the model to deviate from its intended behavior. So one emerging concern is indirect prompt injection via content. Attackers can craft inputs, for example, an email, chat message, or web page text that include hidden directives for the AI. So when the user's AI assistant processes this content, the hidden instructions trigger unauthorized tool use through the MCP server. So, for example, a very prominent case is the GitHub MCP server attack, as you can see on the screen, where the attacker creates malicious MCP issue in any public repository the victim might interact with. And in the issue, you can see that the attacker is asking the AI agent to read the README of all rebels, no matter if they are private or public, and gather the private information from the author and send it back to the attacker. So in this way, hidden commands redirect the AI to access the private repository using the GitHub token, and then sensitive data gets exfiltrated through the AI's response, disguised as a helpful analysis. And another critical pitfall is the presence of malicious MCP server tools, because MCP allows anyone to develop a server. An attacker could distribute a tool plugin that looks useful or benign, but under the hood or in a later update, it performs evil actions. So two most common patterns you should watch out for are the rug pull update. So this is when you might install a tool that initially looks safe and it indeed behaves normally at first, but days or weeks later, it auto updates or alters its behavior to do something malicious. Another pattern is the tool shadowing. So if an AI agent is connected to multiple MCP servers, a rogue server can attempt to shadow or hijack calls meant for another server's tools. And by intercepting or impersonating the trusted tool's functionality, the malicious server can perform actions under the guise of the legitimate one. And then a particularly novel MCP-specific vulnerability is tool poisoning. This was brought up by a research by Invariant Lab. So this is a form of prompt injection that originates inside the tool itself. So these descriptions are provided to the LLM, so it knows what the tool does and how to use it, but are typically not shown to the end user. So an attacker can exploit it by inserting instructions that only the LLM will see, effectively poisoning the context that the AI uses to decide how to call the tool. So in one case, and this from the research by the Invariant Lab as well, the tool's docstring includes a hidden important section, as you can see on the screen, that instructs the AI assistant to quietly read a private file and supply it back to the attacker as a secret parameter side node whenever the add function is called. And then last but not least, MCP servers often needs access to user accounts and data, which means tokens and credentials are concentrated in one place. So this creates significant risk if those credentials are compromised. So two major scenarios of concern are OAuth token theft and account takeover, and also overbroad permissions and data aggregation. So with all of those pitfalls in mind, I want to give you like a summary of the recommended best practices and mitigations. And note that these are my own recommendations. It tries to give you a reference. You don't have to follow it to the T, but I research and I think these are pretty good best practices to begin with. So the first set of best practices that you should do immediately, I categorize it at P0, is first don't pass users token through, because if you forward a user token if you forward a user's login token, anyone who sees that token can act as a user. So you should have the gateway remove the user authorization header and use a short-lived credential specifically for the connector instead. You should also always check tokens on the server. So make the server check the token's audience, issuer, and expiry every time. You should stop services from listening to the whole internet. Basically, don't do what MCP inspector was doing before. You should require signed connector code and stop auto updates. So only install connector builds that are cryptographically signed and turn off automatic updates in production. And then make destructive actions require a human input. So if an action would delete or change data, show it to a person for approval before running it. And then you should also sanitize inputs, right? So strip control characters, normalize white spaces, remove code fences, and run simple validation tools on any user or store text before it's used in a prompt. And lastly, validate the model outputs before executing tools. So again, do sanity check for generated tool calls, and then have a allow list, block or require review for anything outside those allowed lists or whitelists. And then next, these are the actions that you can do near term. So like within days or weeks, you should add quick safety checks to your deployment pipeline. Add tests that check, is this server publicly reachable, or does it accept requests from any other origin, or does it accept tokens with the wrong audience? And limit what each tool can do. So give each connector exactly the permission it needs and nothing more. And you should also sandbox new tools before they are trusted. So start new connectors in an isolated environment and run a small mock test before making them safe. And don't send secrets to external models. So strip secrets out before sending anything to external LLM or use your own private model. And then in the midterm, you should create a catalog of approved tools. So keep a registry where every entry is reviewed and signed, and harden the gateway if your organizations are using MCP gateways or LLM gateways. So you should harden these because now they become like high value target for these attacks. And centralize your logs and traces. So always propagate a trace ID and keep an immutable copy of logs for investigations. And if possible, automate containment steps. So have scripts or playbooks that isolate a server, rotate keys, and revoke sessions automatically when triggered. And then in the long terms, these can become like your company policy, something that you require everybody to follow. So you can require side releases and review workflows. So use protected branches, side releases, and multi-person approvals for big changes. And if you are using LLM as a helper for your gateways, I would suggest that keep them as helpers, not the final decision makers, because there's always a risk of them hallucinating. So keep blocking rules deterministic and require human approval for B0 items. And then keep dependency lists and scan them regularly. So maintain this list and fail builds if unexpected transitive dependency appears. And lastly, run regular red teams and audits. So schedule quarterly tests and catalog rejects. And after I give you all those best practices, I also want to give you something kind of concrete so you could apply your knowledge to. And due to that, I want to suggest using a threat model process so that you can prioritize your real risk, do CI checks that you can run, and a short incident playbook that you can use immediately. So in this threat model process, you can think of it as like a repeatable checklist you can use on any MCP deployment. And again, this is my suggestion and recommendation. You don't have to follow them to the T. But here in this process, we should start with scope and access. So you start by naming what you are protecting, or whether they are API tokens, tool connectors, user data catalogs, or the gateways themselves. So be explicit, say where secrets live and which components hold privileged access. And then after that, you should identify the actors who can touch these assets. Are they external attackers, compromised third-party tools, gateway admins, insiders, and even the LLMs or tool maintainers? So naming these actors will help you write concrete abuse stories. And then the next step is to map attack surfaces and flows. So draw the flows from the client to the gateway to the server to external service. And then in the flow, mark the trust boundaries. It could be auth, runtime sandbox, catalog. This is where we visually find weak links. And then you enumerate the threats and the attack vectors. So for each flow, write down how it can be abused, either as token theft, ROM injection, connector exfiltration, etc. Keep it practical so that you can prioritize the ones that can actually hurt you. And then you assess the likelihood and impact of each of these threats. So score each threat by how likely it is and how bad the fallout would be so that the teams don't waste time on low impact stuff. And lastly, you should have a plan to mitigate and prioritize. So pick 1 or 2 high leveraged controls for P0 items and turn those into CI tests, runbooks, and scripts that you can run. And again, if your company is using gateways, then treat these as service that you would protect with the highest standards. And again, so I'm just showing like the idea of having gateway as the control plane again. I know that OBOT and like a lot of other organizations are beginning to adopt MCP gateways and LLM gateways. So again, since these are the natural control plane for MCP adoption now, you have to really defend them as your highest priority items. And lastly, I just want to leave you with an example of how you can design a threat model matrix based on the threat model process that I was showing you before. So this is an example where you can have like different columns for the threat ID, the attacker goal, its impact, the likelihood, the priority, and then you can draw out like the flow for each scenario. So for example, the first row is for token theft. Token theft is one of the most actionable risks. So if an attacker gets tokens, they can impersonate user or agents. So you should make tokens short-lived, validate audience claims, and avoid accepting bearer tokens forwarded from untrusted clients. And then since I mentioned a lot about the gateways, I also want to include an appendix on how you can treat attack threats towards your gateway. So whether it's your MCP gateway, your LLM gateway, or your webhook, you should also keep in mind like some kind of procedures that you can do in case these are compromised. And I think that's time for me. And thank you so much for listening.
Hailey, that was fantastic.
Yeah.
And enormously comprehensive.
A lot of content.
Yeah.
What I really like is that it's like there's a set of security issues. Like you really need to be aware of what are the security issues that come with MCP, just like with any technology. You know, if you're developing web or database or anything, there's always some you need to know about the security things. But right now, there are some kind of practical solutions. I liked your recommendations, that kind of P0. You know, that's going to get you pretty far. You know, until we kind of get even better at this, or you know, find new new issues. But it's kind of like the world is not on fire. You know, it's like it's a new technology brings new security things we have to consider, but then you know we're figuring out kind of practical ways to deal with it.
Yeah, because like I'm surrounded by a lot of interns at IBM, and when MCP came out, they are very excited to adopt them without really like thinking about the securities threats that could happen. So if they see like a third-party MCP server, they're just very excited to adopt it right away into enterprise like programs and applications. And like I started reading about these like real-world incidents, and I'm like, oh, you guys should stop and kind of read the code and try to like kind of filter it out first before you use them. And also a lot of the talks and tutorials I read, even though they list out the mitigation and best practices, I feel like they're very abstract still. Like we have companies that are building tools like MCP gateways to help us like manage just like sessions and authentication. But like if your company wants to do this yourself, how can you start? So that's why I thought giving people an idea of making the threat model matrix could be a good start.
It's interesting, Hailey, because I think in a lot of ways, I actually think most companies that I'm talking to are somewhat aware of the potential risk of MCP. Like just, you know, especially the bigger the company is, the more likely they've already set some guidelines, or they're at least trying to tell people like, hey, whoa, hold on, think about what we're doing here. Where I think there's actually people getting killed right now is in the personal sector. I think your personal sector of sort of early career developers who haven't lived through, you know, all of the security challenges of web development or cloud native or anything else. I think those people are, you know, they're finding cool MCPs that do cool things that add value to their vibe coding, especially, you know, I think a lot of times the people who are maybe not even highly trained developers, but now vibe coding, they're finding MCPs that can add value to that. So they're attaching it, and those MCPs are stealing their tokens, stealing their data. And so I really hope people who are working on their own are looking at this and really looking at, you know, looking for MCPs. You know, when you deploy an MCP, you better know what it does, and you better have looked at it, and you better be confident that it's something that you want, and definitely think about the provenance of it. Like, where did this come from? Who created this? And almost in the way I would say, if you don't have a very strong feeling that MCP came from a very trusted brand, you know, you better be reviewing the code of it, and you better be looking at it in very close detail. But I do have a question in there. I do think you mentioned the gateways, and obviously that's something we spend a lot of time working with people on, is gateway development. But there's sort of a function in gateways to do filtering, to do some type of a, you know, kind of inbound, outbound filters to look for either bad inputs or bad outputs coming from MCPs. What are some of the key, like if you were, you know, going to say like, here are two things you should be filtering on, that everybody should be filtering on? What are the kind of things that you would like, oh, cool, I have this, I now can write a filter, I can, and these filters can be quite powerful. I think they can even be AI powered if you want to make them that way. But like, what are the filters you would be recommending to someone to prioritize as like, this is what we should be filtering out or ensuring is there?
So like I mentioned before, so for the inputs, like you should try to sanitize it in the way that you usually like sanitize any kind of inputs in other coding practices, like strip like white space, special characters. If there's like hidden characters or special characters, you should sanitize those as well. And then for the outputs, like in the SQL injection attacks, This because the outputs from the tool was like passed directly to the next tool or the agent. So we have to also validate these outputs to make sure that like it's not containing any kind of private data, any information that could be passed on like potentially to external services. And I understand that I was looking into how a lot of companies build their MCP gateway as well. And unfortunately, like a lot of them, I don't really have the actual implementations, but I understand that like if you want to scale it for a big organization, then an LLM or AI could really be useful in helping you triage all these. So like you could have like instructions for the LLM, you could have it in its prompt, and then you can have like blocking rules or like anything that help you like make your work faster. But I would suggest that like with the help of AI, you also have to be careful, right? Because there's always a risk of them hallucinating. So even if you're using them, I would suggest having a human in there as well to triage the output from these LLM helpers and analyzer, to make sure that they are doing what they are told exactly and not hallucinating and came up with something odd, or like even to make sure they are not being poisoned as well.
Yeah, great advice. Hailey, thank you so much. This was great. I really appreciate you taking the time to come on today and join us.
Mhm. Yeah, thank you so much for having me. It was great.
All right. Our next talk is from Misha Kaletsky, who is, as I said, a founding member of Iterate. And he's going to talk about multiplayer MCP client. And I'm very excited for the talk, Misha. Thanks, I know you're joining us all the way from London, so thanks for staying up late. And the floor is yours.
Yeah, it's great to be here. Definitely feels late in London. It's only 5:30 p.m., but pitch black because our clocks changed at the wrong time. Anyway, so yeah, I'll move off this screen to avoid infinite mirror. Yeah, I want to preface this by this has been a bit of a scramble. I want to make sure that I want this to be a kind of practical demo if possible, because these kinds of things it's sort of easier to see it. So bear with me. I'm going to try and show you some somewhat experimental features that we've been working on. So first of all, Iterate broadly, like you said, is basically a bot, which is a hackable multiplayer AI agent. So really, where it says AI agents, we never really wanted to be one of those companies who says like you can have as many agents as you like. We want to keep it simple and say like Iterate is a bot, but you can make Iterate behave the way that you want. And like the key features of it are that it's an MCP client and it lives in Slack, which basically and it is controlled entirely by you through a GitHub repository that's written in TypeScript. And so I'll go through. So basically, because it lives in Slack, you can think of it like ChatGPT, and it can do everything ChatGPT can do, and or any of the other models. And so you can add MCP servers, of course, but I think there's this key feature, which is that it's multiplayer. So it knows it. You can teach it about who you are, who your team is, and then you can have multiple people talking to this bot. It connects the tools, of course, via MCP. That's why we're all here. Like I said, it's customizable via TypeScript, which I'll show you a bit later on. And then there's also, I think there's a ton of stuff that Hailey mentioned that I definitely want to think about very hard. Right now we have some like key primitives here. So we lean pretty heavily on the kind of platforms that we're building around. We might expand beyond Slack soon, but things like human in the loop, we actually implemented pretty fast, because basically instead of calling a tool, the agent will send a message saying, do you want me to call this tool? And if you react with a thumbs up via Slack, it'll execute it. There are kind of additional layers you can add if you want to say, are you really sure you want to call this tool? But that's the basic idea. So things like human in the loop kind of fall out of the architecture of this bot. Why MCP is probably similar to the reason that people like MCP in general. But you can think of Iterate as an MCP client. So what we've actually found ourselves doing over the last few months since building our latest iteration of the MCP client is we've been removing a lot of tools that we had already. So we had these first-class linear, Notion, post-hoc tools, and we've just said, okay, we're going to replace that with information about the MCP servers that we want our client to connect to, as well as some prompts to say, like, this is the best way to use some of these tools. And we're always going to be curating those to make sure our bot is as effective as possible. But the idea is that you can connect to anything. And we found, like the other day, someone on the team just sort of tried out, it's called Get Dialer, which has an MCP server, so you can authenticate. Our bot knew nothing of this, but entirely via Slack on his mobile, he was able to kind of start a phone call to someone else on the team just by chatting through Slack. Obviously, there are better ways to make phone calls on a phone, but it was a kind of good proof of concept. Just quickly about the architecture of Iterate, it's very heavily dependent on Cloudflare's durable objects, and in fact, the agents SDK, for anyone who's interested. And I should have mentioned as well, on the very first slide, I think I had github.com/iterate/iterate. So if anyone is kind of interested in diving deeper on the technical implementation of some of these things, everything we're doing is open source, and you can, if you're really interested, you can see some of the scramble that we've had to get get a couple of things working today. So the basic implementation is Cloudflare workers, durable objects with the agents SDK wrappers, and event sourcing. So we've kind of implemented an agent loop similar to what you get in Claude Code, by basically modeling everything as an event, because somewhat unlike Claude Code, because this lives in Slack, you can easily just have a conversation, a threaded conversation that doesn't get a response for 6 hours or something. So basically, everything is modeled as an event. There's Slack webhook events, and there are agent events when it gets results from MCP tool calls, for example. Another thing that we found it useful to do that I think is somewhat outside of the norm in terms of MCP clients is we have a tool call for connecting an MCP server. So this is why Hailey's talk is something I'm going to definitely be thinking about, because we put a lot of the onus of how to safely use MCP servers onto our users, and we're kind of always providing guidance and working closely with customers. But basically, if you say, I want to connect to this MCP server, and you provide a URL, or you say, go search the web for a URL for this MCP server, which would be a little on the riskier side, we have a tool to connect to that MCP server. We, right now, we don't have .mcp.json like some of the existing MCP client implementations. You basically just say, because what we really want to be able to do is just drive everything through Slack with some configuration in GitHub. So under the hood, this is kind of how it looks in our code. This is obviously a little simplified. And our system handles OAuth, so you'll see like a connector linear button. It'll open up a browser window. I may be able to show you some of that later, but we'll get to it. So this dynamic tool loading, under the hood, we're firing an MCP connect request event. We see the OAuth flow, the user authorizes, and then once the connection is established, the tools are discovered, and they are automatically injected into the agent context again. So this is a kind of something that you definitely want to be aware of it working that way when you're using this for work in terms of security. But it can lead to a really smooth experience. And then in our server, we basically map these tools into the OpenAI callable function format and turn them into regular tools that our agent loop is then able to call. And I can show you a kind of a detailed example of basically the event log and how that looks in our backend system. But the upshot is the agent now has access to this tool. So this is standard MCP server stuff. Another distinction that is somewhat unique to us is the difference between a personal MCP server and a company MCP server. So because this is a multiplayer agent, most of our customers, who tend to be startups and founders with anywhere between 2 and 10 people, they'll have multiple people there, and I can show an example of this. A linear, just as like an issue management software, my linear view is going to be different from my teammate's linear view. And if I say something simple like list my linear issues, the bot needs to be smart enough to say, let's call this tool from the linear MCP server on behalf of me rather than on behalf of my teammate. And again, I can show you an example there. And then there are certain MCP servers that either don't support this or there's no great advantage to just dividing it up by user. So in our case, we use Posthog for our analytics, and they have an MCP server, but it just requires an API key. So we have a way of providing that API key so that the MCP server can authorize, but you're basically just saying like, what errors did we see today? But that's in what we call company mode. So we have to have a system where we map from a user to what's called a kind of MCP connection key. And it gets pretty complicated because we can have multiple MCP server instances for the different people at the company. So yeah, this is a little more on roughly what it looks like, what our implementation looks like. But so you can see it's all these basic primitives. And the nice thing is here that if you're curious about how our MCP server implementation, MCP client implementation works, it's all open source. So you can kind of go and search for some of these strings in our repo, and you can find them and ask questions. And we get customers like helping us make improvements that are usually serving them, but obviously everyone gets to benefit from them. Some technical bits that, again, are a little different from some of the MCP client implementations that you'll see. So we have lazy connections. So if we're aware of a tool, but we don't have an MCP server connected, we can keep the schema for that tool and the description for it. And under the hood, since we're wrapping the implementation of these tools, we will connect to the server as part of the tool call and fire off all these connection events to make sure the user is authorized. We can handle all the things you'd expect from a Slack bot, so text, images, audio, MCP resources. We've also got, so like I talked about, since we have multiple people, since we have multiple connections, and we have to find a way to map from, we say like one tool exists, but depending on which user calls it, we're going to do a slightly different thing under the hood. And I think I also wanted to note here that our LLM is not smarter. So we haven't got into fine tuning. It's something that we may do at some point, but and again, I hope I can show an example of this, that our LLM does dumb things just like everybody else's. It hallucinates, it gets things wrong. We haven't done enough prompt engineering to make sure it uses Notion linear exactly right every time. But this agent loop concept that I think has made tools like Codex, Claude Code, and OpenCode really successful is that it does something and then it has to kind of figure out, am I done here? Should I stop responding? Should I just say like, here you go, I've solved your problem? Or does it need to make another LLM request? And I think our tool, more than most others, you can see exactly that mechanism. You can see what it tries to do. You can and you can kind of trace where it's gone wrong, and the end results are much better, we find, because of that. Roughly, and this is just for anyone curious about Iterate, because it's because there's an open source SDK. So if you are using the Iterate bot, you'll have an iterate.config.ts in a GitHub repo that either we manage or you can manage, and you can use our SDK, which is open source, but also the entire thing is open source. So we have a concept called an operating system, which is basically our Cloudflare deployment, which has all of the brains of the whole bot. And because all of it is open source, if you want to, you can host it yourself. But if you're using our Iterate bot, we basically we try and keep it really, really simple, and we charge based on token usage. So it's a markup based on token costs. A key concept for us, and this links into MCP in a way I'll show later as well, is this iterate config, which is just TypeScript. So you can pull in anything you want. You can define your prompts the way you want. So none of our customers have said, yes, this is perfect, when we say, this is our bot as it's configured basically for our company and in a way that is that we think will be useful for startups from day one, but all of them always start kind of tweaking these prompts and taking them where they want. I can talk briefly about what matches are as well, but this is basically a way to say this is a rule. It's kind of like a cursor rule. It's basically saying if this condition is true, then you should behave like a pirate. So in this case, it would be always. So yeah, these MCP servers make our agent really extensible, and we can kind of do the part of making the brain of the agent work. So this is the part that may be even more rough around the edges. I'm going to try and we've recently introduced Slack Connect support. So I'm going to log into our staging deployment, which we have been deploying in a fun way today. And I'll show you kind of what it looks like if you are a founder starting up and want to log in. So bear with me here. I'm going to use one-time password login, and let's see if we can get in. So this email-based one-time password login is actually only enabled in staging, because what we really want to do is make sure that the bot can connect with tools. So obviously it's a lot more useful if you're signing in with Google or signing in with Slack, and then that Google account might be linked with Notion, might be linked with Linear, and might be linked with a lot of other tools. So it makes it much smoother to onboard to other tools. But obviously it's we're trying out just to test out our onboarding flow. So this is what you'll get to test out with us. So because we found a lot of customers don't have admin permissions to add the bot as like a fully fledged bot to our workspace, and just want to try it out with a Slack Connect channel. Anyway, so I'm going to invite myself with a special suffix to a Slack Connect channel, and there we go. Let's see. And then this is where you'll have to bear with me a little bit. Let's see, did I get a new email inviting me? Yes, here we go. A new message. So I'm invited to work with myself on Slack. This is obviously not exactly what the experience would be like, because I'm having to switch between windows just to make it seem like I'm a new person. But so this is actually what it would look like if you've never even used Slack before. You can still get started with it. I'm going to get another email this time from Slack, since I'm now a new Slack user, according to them, because they've never seen this email address before. And this is the Slack web client. Again, most people are going to be using like a single Slack instance that they're not using for the first time and flooded with tips. So you can see this is the preview version of our bot that is already kind of thinking about whether it needs to reply to this Slack bot auto message. But basically I can say hi, and now we've got a bot. Yeah, so another thing that it's worth mentioning is that we also have we're testing out MCP servers probably as much as anyone is. So we ended up writing again in the last couple of days. So bear with me if this doesn't work. We have a mock MCP server that is publicly available for people to use if they want to test out their own MCP client implementations. And this is quite a good way of saying, like, you can connect to an MCP server that our bot does not know about yet. So let's see. So this will basically use Slack features to say, let's authorize with our mock server, and let's see if our mock server is working. Okay. So this is a bug. I have to go through onboarding twice when I'm using email one-time password. I should already have a trial, so hopefully it just lets me complete onboarding again. Sorry about this. And I need to make sure I'm in the right bot. So let's see if I can get to it this time now that I've gone through onboarding. Yes. So I'm going to use an auto-generated user, but you could log in with any email address and password, and then it should take me back to Slack. Again, I'm using the Slack web client, but imagine I came back to Slack, and since I didn't get the deep link, I may have to say, are you connected? And let's see if the bot is smart enough to figure that out. Yes, so the bot is connected. what tools do you have? So you can see it actually even shows in the typing indicator. It can show a little bit about what some of the previews. So prep for demo beta. So I'm going to create a note to prep for demo beta, and then it should be able to call tools. And I think anybody watching this will have seen how MCP tools work. So I kind of want to switch back, and I can show you, since this is all a demo, you can imagine how this would look if this email address had a real Notion space and had a real linear connection. But I can show you an example of what it looks like when it's connected to basically a real company, because we want to make sure this is useful for founders, for startups. So this was an example I alluded to earlier. List my linear issues, and then it gave, here are my assigned issues in linear, and then I asked it to list the Notion pages I've written. And again, this was after I went through the similar connection flow to Notion. Here are the pages that I had authored. And then, like I was talking about earlier, I also want to know what Rahul's linear issues are, and not necessarily mine. And this is where it gets really, really useful when you're working in a team, and you can kind of find out if anybody is kind of stepping on each other's toes and working on conceptually similar stuff. So this allows us to list Rahul's linear issues. I also I want to show you a little bit about how this looks in our dashboard, because if for the more technical folks, and please interrupt me if I'm going long on time, but I'll just show you a quick preview of what this looks like. So basically, this is our agent debug view that will show me, was the first question I asked. It's a bit uglier because we want to show all of the gory technical details. And you can see tool calls. So first it had to connect to the MCP server, and that happened under the hood from the Slack point of view, but we want to keep everything as visible as possible. There were some message edits. It's listing issues, and then it sent that message. And this is the kind of Slack markdown. We could probably do a better job formatting. Then listing the Notion pages I've written. This is, I think, a really good example of how our bot is not that smart, but the agent loop makes it very powerful. So first it authorizes with Notion, and then it starts having problems. It starts sending these kind of useless, it starts doing these useless MCP tool calls, which I'm sure everybody has seen many times. And it gets an error message. It's saying like invalid arguments for the Notion search, code too small, minimum 1. So the query needs to be something of note. And then it starts trying out different things, and it's kind of gradually teaching itself about stuff. So first it tried to use my Iterate user ID to search within Notion, and it got a problem saying that user didn't exist. So then it realizes it has to get the users in Notion. It then does another search, and eventually it actually finds the Notion page that I've written. So that was, so this is a kind of classic agent loop thing, but what we found is that combining it with multiplayer, and it's something that you can access on your phone, was something quite novel, and we found super useful. Yeah.
Misha, this is really cool. I know one of the things you were kind of going to hit on was sort of how multiple users kind of interact with this, and you deal with identity in there. I don't know if you've got a couple seconds to kind of hit on that, or demo, maybe not demo, but just at least explain, because that was super interesting to me from a conceptual level. But I didn't quite see how you did that.
Yeah, so it's so basically when we're wrapping these tools that come from the MCP servers, we inject and impersonate, depending if it's a personal mode connection, we will inject an additional property on the schema called impersonate user ID. And that basically tells our backend, okay, this is the user ID that should be making the search, in this case it was Notion get users, that should make the request. In the case of Notion, I think their search doesn't have a list my pages API, which is why it tried to use my user ID for something else. But so maybe an easier example will be, you'll see it's a familiar format in linear. Yeah, list issues. it's doing that same thing. It's injecting my impersonate user ID. So then we intercept that tool call because we've got this slightly modified version of the linear MCP list issues tool. And then we say, okay, we know what this user ID is. We have the MCP connection. We have this mapping from basically from user ID to MCP connection. And then we will look up that MCP connection in the durable object, and then we'll invoke the tool call under the hood using the correct, authorization headers, basically.
So this is fascinating because, like, from a technical perspective, like having worked in all these areas or whatever, like what you're doing is very impressive. It's very cool, technically under the hood and stuff. One question I had is when you're like, if you're in a Slack channel and you type, does that always go as the input to the agent? So like the agent is getting because that's one of the things with when you get into multi-user that's kind of weird is like, does the agent observe the entire thread, or does it only respond when you say @agent? Or if you just, how are you handling, kind of that?
Yeah. So basically right now it is, we've kind of gone back and forth on this, and I don't think we're done with the kind of heuristic. And actually what we want to do is have the agent have at least some ability to decide when it wants to jump in or not. But basically the rule of thumb is if it's a top level thread or a thread where the agent has not been mentioned, it's not going to respond unless you @ it. Once you're in a thread where it has been mentioned, it will basically respond to every message. It can, if the message is something like stop talking or something else where it's clearly not needed anymore, it will kind of decide to shut up on that thread until it's mentioned it anymore. But what we're kind of moving towards is basically the agent deciding if it's useful to jump in or not, because there have been some cases where people will ask a question and nobody answers because they're not online, and then we've wanted for a few minutes later the agent to say, like, since no one's answering this, I just looked up everything and cross-referenced all your Notion pages and linear issues, and I think this is the answer to your problem. And we've found it's able to do that if you @ it, but if you don't think to @ it, and we found a lot of our customers kind of, in some cases, I've got to be honest, they forget the bot exists because there's a lot of AI tools out there. So we're kind of going back and forth on that, but right now it needs to be triggered. You need to say @iterate.
That's
for
cool.
it to get involved.
And the response, I'm just kind of curious if, like, when the agent replies, because you're sending the message to an agent has a response. Is that response is what gets sent back to Slack, or does the agent have to call a tool to reply to?
Yeah. So right now it's you may be able to see this. So that's it's actually a tool called Send Slack Message.
Yeah.
And this
cool.
is our most frequently used tool. And we've chatted with folks at OpenAI who've said we're using the responses API rather than the chat API.
Yeah,
and they've said, like, this is kind of the direction things are going. And we're trying to, like, break that assumption that everything is like user assistant. We do use, so we use system prompts, of course, and then user messages, but even the user messages, they're kind of formatted based on Slack webhooks. So it kind of says, it says you've received a webhook that looks like this. And then actually, a nice thing, and again, all of this is open source. You can see when we have a core LLM request start event, that's one of our important events, you can actually just see the raw request, exactly what we send to OpenAI, which we found has been really useful. And we've kind of started to use tools like Brain Trust less and less because you can see exactly what's sent here, and you can see the bot added reaction eyes from the Slack message, so it gets all of this context, and this is what a user message looks like to the bot. And we found it's
a fascinating pattern that I've seen, because it's cool that you're doing this. Is like, because you kind of get trapped in this model with a chat bot where you have kind of like user assistant. So you think like I have to tell it something and it has to reply to me. But if you flip your paradigm, and it's kind of what you've done, which I think is beautiful. That's why I really appreciate what you've done. Like, this is really good. Is if you flip the paradigm, thinking that the agent is an agent that is capable of doing things, and the input, just treat it more like an event. So you just tell the agent, this is what just happened. You decide what to do. So if you just say a user has typed this message, if it's applicable, then you should call the tool. Otherwise, do nothing. You know, so it's like it has the ability to choose. And so the response to that agent is from that agent to a certain degree. You know, to a certain degree, if you really optimize things, you could ignore the response. But the response of the agent would just be like, I have now sent that message to, you know, but you would probably prompt it and just say like, don't really reply back with anything.
Yeah. Well, no, I mean,
it's kind of useless. Yeah.
If you search for do nothing in our code base, you will find a tool called do nothing, which we found really helps to kind of break that assumption that is basically in the training of these LLMs that says like you have to respond, you have to do something. And so if the something that they do is a tool called do nothing, then you know we consider ourselves done. And
yeah, there's also this weird assumption if you give LLMs tools, it gravitates towards thinking it needs to call a tool.
Yes.
So it's a brilliant hack of the
yeah. It definitely is a hack, and we're definitely thinking about like whether we can change this or whether it would be useful to, because sometimes the bot replies when I don't think it would be appropriate.
Yeah, I mean, I love hacks. You know, at the end of the day, I just, you know, we want to provide some value and functionality to someone. Whatever works.
Yeah.
So,
yeah, exactly.
This is great. I think I love I love what you've done. I mean, so many good patterns. This is what I like is to see these really complex things like tool scaling and identity and stuff like that. Of like, as we get into it and we figure it out, it's like the pattern's not rocket science. It's often a lot of code to implement. You know, it's like, especially if you start doing identity with OAuth, it's like freaking madness.
Yeah.
But the pattern makes sense where it's like, okay, I can easily reason about this. This makes sense. Dynamic tool discovery, all these things. So it's cool. Like I like when MCP started, I was very skeptical of, you know, people were expecting magic, and it's like, I don't know if magic will work, but it's working. Like it's pretty cool.
It is.
Do this. Yeah.
Yeah, and there are a couple of things I wanted to briefly touch on. So first of all, a lot of this MCP stuff was implemented by Zach Davidoff. So follow him on Twitter if you're watching along and you're interested. And I also wanted to talk about just code mode as something that's coming. So I don't have much to say on it, but we're really, really excited about Cloudflare's dynamic worker loading. So basically generate some TypeScript and run the TypeScript. And we found our early experimentation, it does that. It can solve like a lot of MCP problems kind of disappear, and you can start working with those servers of MCP servers where they're just low-level operations. So I know a lot of the guidance has said like you have to have a very broad thing like onboard a user as an MCP tool. We found that with code mode enabled, so basically generate TypeScript, you can actually just have almost open API endpoints wrapped as MCP servers, and it works.
Yeah, and the super cool thing about MCP is because people will throw out issues with MCP and say, oh, it's bad because of X, Y, and Z. But what I've found is it's like all issues in MCP can be solved with MCP. Yeah. So the code mode MCP is kind of very interesting, where it's like, well, it's way more efficient if I just generate some TypeScript. So it's like, okay, well, I just create a code mode MCP server that you then give it a series of MCP servers that has a little bit of code in there, and through sampling and whatnot and blah, 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 like you can make that work. So it's like, oh, well, I just needed to because like you can create a dynamic tool calling tool calling MCP that you just give it a series of MCP. So it's like these patterns are emerging, and it's really cool. The code mode one is amazing. I'm a fan. Like I would not say I'm a fan. I was very negative towards it when it came out, but I've grown to appreciate it. So that's that's cool.
Yeah,
guys, we need to wrap up. This is great, Misha. I really appreciate you coming on today. Hailey, likewise. Thank you guys. This was an excellent set. Lots of great content, lots of really good examples. Misha, congrats on the company and the startup. And Hailey, please keep doing the amazing research and sharing it with people. It's enormously valuable at this stage in an ecosystem. So, Darren, thank you as always for jumping in, and we'll see everyone next week.
Awesome.
Take care.
Thanks very much, everyone.
Bye.